This is SpaceTime Series 25, Episode 96, for broadcast on the 14th of September 2022. Coming up on SpaceTime, 4-billion-year-old planetary crust found under Western Australia, a new hypothesis for the origins of Earth's water, and it works in the movies, but would suspended animation or stasis really work for long-distance spaceflight? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have identified a 4-billion-year-old piece of the Earth's crust, roughly the size of Ireland, underneath what is now Western Australia. The discovery, reported in the journal Terra Nova, is among the oldest segments of the planet's crust ever identified. The oldest currently known slice of planetary crust on Earth is the Canadian Shield on the eastern shores of Hudson Bay, which has been dated to 4.3 billion years. That's just 300 million years younger than the planet itself, and 200 million years after the giant Theia impact, in which a Mars-sized planet slammed into the early proto-Earth, eventually giving rise to the Moon. The only older stuff originating from the Earth are zircon minerals dating back some 4.4 billion years. They were found at Jack Hills in the mid-north of Western Australia. Finding really ancient rocks is difficult on Earth because the planet's crust is constantly being weathered by wind and water erosion and through seduction back into the mantle due to plate tectonics. This means that most of the planet's surface rocks are at very best only 1 or 2 billion years old, and most are much younger than that. One of the study's authors, Max Drollner from Curtin University, says finding much older crust suggests that something special must have occurred during this epoch in Earth's history. The newly discovered section of ancient crust was found in sediment from the Scott Coastal Plain south of Perth, which eroded out of much deeper Australian continental rocks. The authors reached their conclusion by undertaking radioactive dating of zircon crystals found in the rocks. Zircons are extremely durable crystals that resist melting and erosion once they're formed. That means they often survive the very rocks they formed in. The authors vaporized the zircons using powerful lasers, then analyzed the decay ratios between two radioactive elements they contained, uranium to lead and luteum to hafnium. Because these elements radioactively decay at set rates, they can be used as geological clocks to date the zircon minerals they were formed in. The authors then used Earth observation satellite data to learn exactly where these minerals came from. Because Earth's crust varies in thickness, gravity varies slightly across the planet's surface. And by measuring these variations, the authors identified a thick section of crust around the Scott River region, which is part of the massive 100,000 square kilometre Yilgarn Craton, which covers a third of the state and includes Jack Hills to the north. This ancient crust is buried tens of kilometres below today's surface and includes a boundary area associated with gold and iron ore deposits. Understanding the formation of crust 4 billion years ago will help researchers better understand how our continents first formed. This is SpaceTime. Still to come, a new hypothesis for the origin of Earth's water. And it works fine in the movies, but could suspended animation, in other words stasis, really work for long-distance spaceflight? All that and more still to come on SpaceTime. A new hypothesis published earlier this year suggests that Earth received its life-giving water during its formation in the protoplanetary disk from which the Sun and Solar System were created 4.6 billion years ago. The findings, which were reported in the journal Nature Astronomy, were based on a detailed evaluation of the hydrogen-to-deuterium ratios in water of an ancient meteorite as old as the Solar System itself. Water is essential for life as we know it. It's made up of molecules of hydrogen and oxygen. A hydrogen atom is usually made up of a single proton in its nucleus orbited by an electron. A heavier version of hydrogen, called deuterium, adds a neutron to the proton in the nucleus. For years, scientists pondering the origins of Earth's water were convinced it must have come to the Earth through comet and asteroid impacts, which reached their peak some 3.9 billion years ago during a period known as the Late Heavy Bombardment. This was caused by the migration of the gas giants Jupiter and Saturn from the inner solar system out to their current locations. Now, the reasoning behind this water origin hypothesis was the enormous amounts of heat generated during the Earth's formation, which saw the early proto-Earth as nothing more than a seething, bubbling magma ocean, especially after the Mars-sized planet Theia slammed into it, blowing off so much ejecta it eventually coalesced to form the Moon. So, with the Earth being nothing more than a molten magma ocean, it was thought any water that would have been there would have evaporated away. So, how did the water get here? Well, astronomers always thought that comets, being basically big muddy snowballs which contain a lot of water, may be a good contender. However, the problem is, when astronomers began analysing the composition of water inside comets, they found that the hydrogen to deuterium isotope ratios were different from that of Earth's water. It turns out the further away from the Sun you get, the less deuterium water contains. And comets originate a long way from the Sun in the outer solar system. So, if Earth's water didn't come from comets, where did it originate? And this is where geochemist Jerome Allion from the French National Museum of Natural History comes in. He was studying the 4.57 billion-year-old Efremovka meteorite, which was discovered in Kazakhstan in 1962, when he analysed the hydrogen in its calcium-aluminium-rich inclusions, or CAIs, using a new technique involving a focused ion beam. This meteorite analysis showed that during the first 200,000 years of the solar system's existence, and before the planetesimals had formed, two large gas reservoirs existed. One of these reservoirs contained the solar gas from which the matter in our solar system ended up condensing. The other was apparently rich in water from a massive influx of interstellar material that fell in towards the inner solar system just as the protostellar envelope was collapsing to form the Sun, and before the Earth had fully formed. And fascinatingly, this interstellar water had a similar isotopic composition to Earth's water. A full report on the discovery is contained in the current issue of Australian Sky and Telescope magazine. The magazine's editor, Jonathan Nally, says this suggests that the water was present in the early solar system from its very inception and before the Earth was formed.
G'day, Stuart. Yeah, so where did Earth get all its water? But we're the water world. We've got all these huge oceans, water everywhere. We've got this magnificent water cycle. We've got Antarctica down there. We've got polar ice caps. We've got clouds. We really are a water planet. So where did all this water come from? And for a long, long time, people thought, well, Earth must have been bombarded in its early years by lots of comets, and there would have been far more comets around billions of years ago than there are now. And comets are made basically mostly of water ice. So bombardment of comets could have brought a lot of water to the Earth, because the thing is, when the Earth formed in the early days of the solar system, everything would have been really hot. The whole environment would have been incredibly hot, and it would have been difficult, if not impossible, for water to form pools and lakes and oceans and things on a hot planet in a hot environment. So the thinking was that after things cooled down a bit, this comet bombardment came along, and that's where we got all our water. So that was the idea for a very, very long time. And the difficulty is that some researchers come up now, and they've suggested that it wasn't courtesy of a bombardment of comets. We might actually have formed with the water in place. And the reason for this is that there are a couple of different kinds of hydrogen atoms, okay? And it turns out that much of the type of hydrogen in Earth's water molecules doesn't match the type of hydrogen, or at least the ratio of the two types of hydrogen that you find in comets. Because comets from way out there in the distant part of the solar system are sort of like frozen time capsules, and they're thought to encapsulate the conditions that they formed in there. So they're sort of like pristine samples of the type of water, frozen water, that they were made with. And the type of water we've got here on Earth, or at least the ratio of the different kinds of hydrogen atoms, is slightly different. So scientists have analysed a meteorite that was found in Kazakhstan back in the 1960s. And this meteorite has crystals in it that indicate that it formed in the hot environment of the early solar system, right, where the Earth would have been as well. Now, the scientists have found that the ratio of the two types of hydrogen suggests that the water was already in and on the Earth when it was forming. Because it matches, you see. And they also think that this particular type of water, or some of it at least, might have actually come from outside the solar system when the solar system was forming and got sort of dragged in and mixed in with all the big cloud of gas and dust from which the sun and all the planets eventually formed as this cloud was collapsing inwards. So that's really interesting. So that we didn't have this. We might have still have had a comet bombardment, but could it have brought enough water of the hydrogen ratio type that we now have? So it looks like we actually formed with the water in place. So we really are the water world and have been for a very, very long time.
There was the normal water that formed in the protoplanetary disk, and then the second body of water infiltrated into the solar system, and it's the second body which the Earth's water came from.
Yeah. So it's interesting to see how ideas change over decades and decades and decades as new evidence comes along.
And get a lot more complicated.
They can get a lot more complicated, but the beauty is that we've got all these new techniques of analysing things these days too. And, ideas tend to sort of stick in science for a very long time, and then something will come along and turn it upside down. For instance, Newton's ideas of gravity and all that sort of stuff, and that stayed that way for a couple of hundred years. And then
they say that science's progression can be measured in tombstones.
Tombstones. Well, you only have to go back probably, about 130 years towards the latter part of the 19th century, the late 1800s, where some physicists at least, were proudly proclaiming all physics is now known. We've sorted the whole thing out. There's nothing more to learn.
We got it all.
all done. And then along comes relativity and quantum mechanics and the atom and all sorts of other things. And what's the pride goeth before the fall, the old saying, isn't it? So it's the same thing with, this is not a major one, the Earth's water, but the idea had been settled on for a long time that the water came from comets. And the other thing that sort of fed into that too, probably starting in maybe it was in the 80s or so, was that they started to detect, amino acids and things in bodies out there in space. And then it was thought that maybe comets brought some of the building blocks of life to Earth as well. So it all seemed to make a lot of sense. And look, comets would have bombarded the Earth too, and some of the water would have come from comets. So maybe they did bring some amino acids and things. But that idea sort of stuck for a very long time until this new evidence came along, when we had new investigations and new techniques for investigating and analysing meteorites and other things that we just simply couldn't do before. So sort of episodic, the way these sort of scientific ideas go. What they had before was the best idea they can come up with the information they had at the time. And now we've got a new idea with the best information we've got at this time. And who knows what it's going to be 30 years from now, when we might have made some huge other discoveries somewhere else. Maybe 30 years from now we will be analysing planets that orbit other stars and be getting all sorts of great information from them, and maybe even pictures, and be able to sort of see equivalents to Earth out there forming or having already formed or in the process of forming, and get some clues then to how our planet formed and the processes that were going on in our neck of the woods about 4.5 billion years ago. It's exciting, actually.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come. It works fine in the movies, but could suspended animation or stasis really work for long-distance space flights? And later in the science report, a new prototype electrolyzer that can convert humidity in the air into hydrogen. All that and more still to come on SpaceTime. Well, it works great in sci-fi, but in real life, putting someone or something into stasis, that is suspended animation, in order to undertake long-distance space flights simply isn't going to work. Chilean researchers set out to investigate whether humans could hibernate like bears, enabling people to remain in stasis during long trips through space that last more than a normal human lifetime. But they found that it's unlikely to work because humans simply wouldn't save enough energy during hibernation. They looked at metabolism during hibernation in mammals, ranging from bats to bears, and say that a gram of tissue in a bat has a similar metabolism to a gram of tissue in a bear during hibernation, despite the bear being nearly 20,000 times bigger. But working out the likely metabolism of a hibernating human based on our mass, they found that we save more energy simply by sleeping than what we would by hibernating. The findings, reported in the Journal to Proceedings of the Royal Society B, are bad news for sci-fi fans, suggesting that humans will simply never be able to survive in suspended animation during long trips through space. A new study has shown that astronauts on long missions experience the equivalent of 10 years of age-related bone density loss even after 12 months of recovery back on Earth. The findings, reported in the journal Nature Scientific Reports, investigated the shin bones of 17 astronauts after being in space and found that people who went on space missions for longer than 6 months had substantially less bone recovery than those who were in space for less than 6 months. Altogether, 9 of the astronauts studied did not fully recover their shin bone total mass mineral density even after 12 months of recovery. Across all astronauts, those who completed the greatest amount of in-flight deadlift training relative to their individual training pre-flight were identified as part of those who did recover their tibia bone mineral density. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. It's often claimed to have been Winston Churchill who coined the phrase, "If you're not a socialist at the age of 20, you have no heart. But if you're not a conservative by the time you're 40, you have no brains." And it seems to be anecdotally true. Have you ever noticed how people often start out with very liberal or even radical ideas, but they become more and more conservative as they age? Now a study reported in the Journal of the Proceedings of the Royal Society B may have come up with the answer. And the key is becoming a parent rather than simply getting older. Apparently, when you have kids, it pushes your social values to the right. Through a series of surveys, scientists demonstrated that parenting motives, parenthood or parental care motivation, such as feelings towards a child crying, fundamentally influence social conservatism all around the world. And attitudes to subjects such as abortion, welfare and national security become far more conservative as the number of kids you have increases. Of course, that also means that the growing tendency to have fewer kids or none at all could contribute to future liberalisation on social issues. Scientists have developed a new prototype electrolyzer which can convert humidity in the air into hydrogen. Because current methods to create hydrogen for energy require pure water that could otherwise be used for drinking, scientists developed a way to use the moisture in humid air to avoid competing for resources. They say their device, which absorbs moisture in the air and splits it into hydrogen and oxygen, could be powered by renewable energy such as solar and wind and can operate with humidity as low as 4%. The research, reported in the journal Nature Communications, could be scalable and could help provide hydrogen fuel for remote and semi-arid regions. A new study has shown that men who receive a positive reading from a fortune teller ended up taking more financial risks following the reading than those whose reading was negative or neutral. The findings, reported in the journal PLOS ONE, also found the link was a lot less pronounced for women than men. The researchers conducted 2 experiments using 293 participants who were given either positive, negative or neutral fortune readings. They were then asked to complete a questionnaire evaluating their tendency to take financial risks. The authors found that participants with positive fortunes were more inclined to take financial risks, especially if they were male. In another experiment, they found that people with a positive fortune ended up gambling more real money afterwards in an online game, although no difference was seen between men and women in that experiment. Now, crunching all the data together, they found the link between positive fortune and financial risk-taking only held true for men. Interestingly, most of the participants didn't believe in fortune-telling, but this didn't affect their outcomes. Apple has launched its new iPhone 14 models, as well as the new AirPods Pro and 3 new Apple Watches. Technology editor Alex Zaharov-Reutt from ITWire.com says it's the most bountiful harvest yet from Apple's orchard.
They've launched 4 new iPhone models, the 14, the 14 Plus, And then the two Pros, the Pro and the Pro Max, they've launched the new second generation AirPods Pro, and they've also launched 3 new Apple Watches, the SE, which is the lower cost version, which is slightly cheaper than the original model of the SE, the Apple Watch Series 8, which has car crash detection and 2 temperature sensors, and also a new Apple Watch Ultra, where every model comes with LTE. They're in Australia $1,299, and they're able to work at incredibly low temperatures. They're very robust with titanium and a sapphire glass screen. Let me tell you a bit about the iPhone 14 model. So all iPhone 14 models have new satellite connectivity. Now, this is coming later this year, and it's for the US and Canadian markets to start with only, and it's going to be free for 2 years. But what it allows you to do is hold your phone to the sky. It has an interface that will show you that you are sort of connecting to a particular satellite. The connection can take several minutes, but once you're connected, you can then send messages. Now, Apple has curated a bunch of messages which are designed to quickly get the message across, because it can take minutes for a message to send or come back. And there's no voice with that yet. But if you are in an area where there's no cellular connectivity, this is something that will eventually be standard on all phones. And it doesn't require a satellite sleeve or a special satellite phone. It'll just be a standard feature of your phone. So iPhone 14 is the first to get it. Now, the iPhone 14 Pro has ditched the notch and has taken a chill pill. So what I mean by that is that it now has what it calls a dynamic island. So it's like the notch has been lowered, and above the what was the notch, you can see a bit of screen. But the notch itself, it's a 30% smaller Face ID sensor and front-facing camera. Front-facing camera now has autofocus as well.
Didn't I tell you when the notch first came out it was a bad idea? I remember saying that to you on air.
Yes, you did. You did say that. For most people, it just effectively ignored it. But now Apple has embraced the fact that it needs space on the screen to maintain a bezel-free environment around the screen itself, and that little pill shape is now dynamic. So that black area can widen in size to show you notifications, to show you that you've had your Face ID successfully scanned, to show you timers, to show you how far away your Uber or Lyft ride is, and it's dynamic. So it moves, it grows, it shrinks, and they've managed to take something that companies have sort of hoped you ignore and made it into a feature that is actually delivering real benefit. No one else has been able to do something like that, and it's quite cool. Also, the cameras on all the phones have been updated. They all now take 2 times better low-light photos, and on the Pro models, there's now a new 48-megapixel main sensor, where each pixel is now made up of 4 separate pixels, so they've merged them together. So 48 divided by 4 is 12, so that's what gives you the 12-megapixel sort of size that you're used to seeing. But if you're a pro photographer, you can actually use all 48 megapixels, and you actually now have a 2 times equivalent optical zoom. So although you only have 3 lenses, you have the 0.5 ultra-wide, the 1 times standard, the 2 times optical equivalent, because it can use that larger 48 megapixel area to take a 2 times optical zoom equivalent shot without zooming up the 1 times, and you've got the 3 times optical telephoto. So the cameras have been improved. They take better photos. The front-facing camera's got autofocus. There are bigger sensors that let in more light. And you've got improved cinematography mode. So that's where you look at something and then something looks at something else and the focus changes. That's been improved. There's also a new action cam mode on all the new iPhone 14 models, where it can zoom in a bit and use stabilization software and hardware to give you an ultra-stabilized shot that is effectively negating the need for a gimbal. But
I just bought a new gimbal, by the way.
Well, I mean, if you don't have an iPhone 14 and you want the stabilized shots, then your gimbal will still get a lot of use, and it can be used with other phones as well. And that is probably going to be even more stable than what Apple has been able to do. But Apple also launched the new second generation AirPods Pro, twice the noise cancellation. When you've got transparency mode, if the AirPods hear lots of noise, like from a jackhammer with construction, it's analyzing the sound 40,000 times plus per second, and it can mute those sort of sounds or make them much dimmer, so you're not being assaulted by this very loud sound. There's a new H2 chip inside that does all of this, and there was talk that Apple would remove the stems from the AirPods Pro, because a lot of the competition doesn't have stems. The Google Buds, the Pixels Buds, the Jabra, they don't have the stems. But Apple has liked the stems because you can squeeze them to pause, play, stop, bring up Siri, go from noise cancellation to transparency. But I've always wondered, why couldn't you just swipe your finger up and down the stem to change the volume? Well, they've done that. So now you've got manual volume controls on the second generation AirPods Pro. The previous ones don't have that, but the new ones will. And that's going to be, the most exciting new AirPods yet. The actual case as well gives up to 30 hours of battery life. The AirPods have 6 hours of battery life. The case can be charged by your MagSafe charger, by a Qi wireless charger, or by your Apple Watch charger. And it's got a new speaker inside to make it easier to locate if you're using the Find My. But also you'll hear sounds when battery's low and when it's charging. So they've really upgraded the case on their phones as well. And they've kept the prices basically the same as what they were, despite the inflation that has bitten everybody, which is great news for consumers who want to upgrade.
What sort of plug does the Apple have this time?
Well, there was lots of talk that they would go to USB-C, and the European Union has mandated that they do that by 2024. So USB-C is still there to plug into the actual wall charger, but the bit that plugs into the phone is still Lightning. Lightning is still a great connection. Most of the accessories are still using Lightning. And, there's even talk that Apple will next year go with a portless phone that has no ports at all. In fact, for the US models of the iPhone 14, they now have dual eSIMs and they have no physical SIM slot at all. Now, I don't think that that's going to be the case in Australia. I think we'll still have a SIM slot here. But Apple's getting rid of the SIM slot. It's one less place for water to get into a phone, one less little piece of equipment that it has to manufacture. It's more security. Nobody can pull your SIM card out. And the other thing that we didn't get with the iPhone 14 this year is no 5G millimeter wave connectivity in Australia. That's still in the US only. 5G millimeter wave gives much faster levels of 5G, like gigabit 5G, like over 1,000 megabits in many places. But you need to have really close line of sight to the towers. Hopefully we'll get it with the iPhone 15 next year.
There's also news from LG and also Google.
Yeah, well, LG has given up on making phones, but at IFA they announced that their OLED screen technology is able to go from a flat screen to a curved screen, and not just one level of curve, but there are 20 different levels of bendability from flat to whatever the deepest curve is. Now, curved TVs were actually available for a while, but people wanted the ability to have both, and at the time they couldn't do it. But now technology has moved so much that LG can have rollable displays, which are obviously super expensive at the moment, but cheaper is this ability to have this curved display. And if you've got a family sitting on the couch, having a curved display might not be the best. You might want to go back to flat. But if you're just watching it by yourself, you're right in the middle in the sweet spot, then having the two curves come out and facing you gives you your eye. It matches the curvature of your eye, or it more closely approximates that, and it gives you more immersion. LG also showcased a bendable gaming monitor, which you can use for non-gaming computer purposes as well, but with the same technology. When will these come out? Probably sometime in 2023. They were just showcased at the IFA Tech Show in Germany, so usually those things take a while. We don't know prices yet, but probably they'll be more expensive as they're quite new. So Google will be also announcing new phones in October. They've made this announcement on iPhone Day, obviously, to get some attention. They'll be launching on October the 6th in the US and October the 7th at midnight for people on the east coast of Australia. They'll have the Google Pixel 7 and 7 Pro, which will have their latest Tensor chip and all the advancements that take advantage of Android 13 and no doubt other surprises. There'll be the new Google Pixel Watch that has been previewed at their Google I/O earlier this year. There will be most likely more information on the new Google Pixel tablet, and there'll be undoubtedly new Google Nest devices, so new generation of their smart speakers and smart screens.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.